All right, how's it going out there, folks? The other day we started talking about erosion of weathered sediments, and we talked about the agents of erosion, right? Wind, water, gravity, glacial ice. Of course, water is the number one agent of erosion, and we're going to focus on that today, right? We're going to talk about how rivers erode sediment. But I also like to call this lesson Where Not to Buy a House. A lot of people don't understand, I guess, how erosion works, and they'll buy this. Everybody likes waterfront property, but there are certain places where waterfront property will not be property very long, right? Because the river's going to take that property away. And you'll see what I'm talking about. So, pretty interesting stuff. Check it out. Starts out with clip of a river here. I put it in a different audio to be a little comical about it, but see if you can pick out the different parts of the river that are traveling at different speeds and what might happen there. Check it out. All right, obviously way, way faster here, more relaxed over there. Look at that volume of water moving there. Woo! Well, if you have been whitewater rafting, this would be a great place to do it. And then all of a sudden you can see the white water kind of calms down. You can see water almost standing up on itself, right? Coming in. Extremely fast moving. But then if you notice toward the outside, right? This is all happening more toward the center. Sometimes on the outside curve. But if you look in a second here, you'll see there are parts much slower. I don't know if you caught it, but there were slower parts. And that's usually on the opposite side of the curve, and we'll talk about that. Okay? So how do we increase the velocity or the speed in a river? There's a couple ways to do it. Bottom line is more speed equals more erosion, right? That's your golden rule there. But there are a few other things. The gradient, of course. So the steeper it is, the faster it's going to go, the more erosion you're going to get, right? Common sense. Then there's discharge. That means the amount of water in a stream. So that's going to vary with the amount of rainfall or snow melt, right, depending on the season. And they'll say oftentimes a river will crest, right? It'll get to its high point a couple of days after a major rainstorm. So they issue this warning. They'll say, hey, we just got 2 inches of rain, could be 500 miles away. Heads up downstream, it's going to crest. And they'll literally track it on the news to give flood warnings to residents if they live too close to a river to evacuate. All right. And then, of course, you have the channel, right? The path that a river follows. Is it straight? Is it curvy? Is it a rocky bed? Is it a smooth bed, right? All those will add friction to either speed up or slow down the river there. Okay? Here you can see crazy curves. These curves are called meanders. And as rivers get older, they develop these curves. We'll talk a little more about that later on. Okay. Check out this graph here. You have discharge. Remember, that's the amount of water. Velocity is the speed. Hit pause. See if you can figure that one out. All right. Hopefully you said the more water, the more velocity, right? Because obviously if you've ever been out to Splish Splash, you go on a slide where there isn't much water, you're not going very fast. But if there's a lot more water, you slide right down that slide. And if you haven't been to Splish Splash, go. What a good time that is. It's out in Riverhead, I believe. About maybe a 45-minute drive or so. Okay, then you have velocity. To hit pause, see if you can figure out this one, velocity versus erosion. All right, hopefully you said the faster it goes, the more erosion you're going to get. Right, more speed, more water slamming into the opposite shores is going to transport that sediment much further. Okay, water again, the number one agent of erosion. So where does this maximum velocity of a straight stream occur? So now we're not talking curve, talking straight. It'll be just below the surface, right? So the wind won't slow it down. It'll be toward the center so that the friction of the edges doesn't slow it down. And from a side profile, it would look like this. The longer arrow, these are called vectors, and the longer the arrow, the faster it's going. So if you look, it's just below the surface here going the fastest. And it's, of course, in the middle here going the fastest. So that's what this is all about. Make sure you get that in your notes there. Okay? So on this graph, if you had to plot it out, what would it look like? Speed versus position. So here's position A, B, C. What would it look like? Hit pause. See if you can figure out this graph. All right. Looks like A is going a little slower than B. C is also going slower than B. So hopefully you had a graph that looked like this. Okay. All right. And here's what I'm talking about where not to buy a house. Check out these pictures, folks. Obviously, you're not going to send your kids out to play in that backyard anytime soon. How about this one? Or this one. See, that's the outcome here. Now, what do all these houses have in common? They were all built on the wrong side of a river. Obviously, they were too close to the river, but there's a certain side that you could build on that would be safer, right? I still wouldn't build too close to a river, but there is a certain side. This happens to be on what's called the outside curve, and you're going to get more erosion because the water goes faster on the outside curve. Same thing here. This is the outside curve of a river, and I'll show you in diagram form what we're talking about. So, see the bigger arrow there. Remember, bigger arrow, bigger vector means more speed. Well, you're getting more speed at B, so you're going to get more erosion at B. Watch what happens here. Sediments come down the river and slam into the shore, and it takes more with it. Now, on the inside, it goes slower, and it often deposits on the inside. So ideally, if you built on the inside, technically you could gain property, right? If all works in your favor, because you get more deposition. Whereas on the outside, if you build here, you're eventually going to lose your house because you're getting more erosion. And there's a beautiful example of a curving meander in nature. You can see on the inside curve, there's a beach developing because of more deposition. But on the outside curve, it's taking that material away. It's eroding it. Okay? So there it is. Get that in your notes. Outside bend, much faster, more erosion. Inside bend, much slower, more deposition. All right? All right. Here's another way of looking at it. We're going to set up a little comical race in a minute here. So the sediment's going, boom, slams into B, boom, slams into C prime, boom, slams into D. What are you going to get? Well, you're going to get erosion, right? B, C prime, and D will give you erosion. It's going faster there. Opposite that, of course, on the opposite side there, B prime, C, and D prime, it's slower. You'll get deposition. Think you got to figure it out? Oh, yeah? Then who's going to win this race, folks? Place your bets, place your bets. Who's going to win, Grandma or Grandpa, based on the curves and, of course, how that'll affect their speed. All right, so just jot down there which one you think's going to win. Be honest with yourself. On your marks. Get set. And they're off. And Grandma takes the outside much faster. Grandpa slower on the inside. But then he takes the outside faster. And Grandma's on the inside. Oh, no! Grandma gets the last outside curve, going much faster, of course, and ultimately wins the race. We'll watch that one more time. Outside faster, inside slower. Outside faster, inside slower. Outside faster, inside slower. Hopefully you didn't lose too much money on that bet, folks. There it is. Oh, hey, by the way, on the bottom, notice when the river's going straight, it's kind of a straight cutout, right? The profile looks pretty symmetrical. However, here, you're going faster at B, more erosion, so it gets deeper there, right? It took material away. At B prime, it deposited material, so it's more shallow. And over here, the outside curve was C prime, so C prime gets deeper, right? More erosion over there. Pretty neat how that works. How does landscape with sediment and sediments appear after water erosion? Well, look at the shape here. Everybody see that? River valley. It is a V shape. And if you can't see it, I'll give you a little, I think I put, oh, I didn't do it on this one, but you can totally see that's kind of a V shape there. And the particles, check these out, right? Nice and smooth and round. I'm sure you've seen advertisements for that, like Spazzle, say, what do they call it? The hot rock therapy, whatever it is. Anyway, they heat up these smooth river rocks and they put them along your spine there. It's supposed to relax you, whatever. But they're very smooth because of being abraded, right? Abrasion in the river over time. There you can really see that V shape right there. Rivers carve out V's. All right, so what you guys got to do, there are 3 pictures in your lesson there. Profiles. You have to put the proper profile at the proper place in the river, keeping in mind faster, more erosion, slower, more deposition, how that would affect the banks. And then you have a couple of summary questions that follow. All right, we'll go through it in the meet. See you there.